A toy is made up of cylindrical rings stacked on a base, as shown in the diagram. The diameter of ring 1 is 87% of the diameter of the base. For ring 2 through ring 7, the diameter of each ring is 87% of the diameter of the ring directly below it. The diameter of the base is 5 inches. Which function can be used to find the diameter in inches of ring R, where 1 is less than or equal to R, less than or equal to 7? Our answer choices are F. D of R equals 5 times 0.87 to the R power. G. D of R equals 0.87 times R minus 5. H, D of R equals 0.87 times 5 to the R power. Or J, D of R equals 5 times R minus 0.87. So the first thing we could do with this is that we know the diameter of the base is 5 inches. And we'll call that 0 here for the R. So the first thing that we have to figure out is if R equals 0, your diameter would have to equal 5. So if we did that for this one, we have 5 times 0.87 to the 0th power. That equals 5. So that one could work. Let's try the next one. 0.87 times 0 minus 5. And that's negative 4.35. That's not 5, so that wouldn't be able to work. Okay, H. If we plug in 0 for R on this one, we get 0.87. That's still not 5, so that wouldn't be able to work either. And then the last one, we have 5 times 0 minus 0.87. And if you put that in the calculator, you'll get the same thing as G, negative 4.35. So that wouldn't work either. So in this case, the only one that could work is F. And notice this is also going to be exponential. G is not exponential, and J is not exponential. Your initial value is 5, and that's the A that goes on the outside. So F would be the only choice that would work here. Okay, 9D, characteristics. Looking at this first graph, our domain is all real numbers. Our horizontal asymptote is that dashed line where the graph looks most horizontal. This could be at y equals 0. The range, you carry down the y, you carry down the 0. The graph is above the horizontal asymptote, so it's greater than. The base is 2, that's bigger than 1, so it's a growth. And the y-intercept is 0, 2. On the next one, domain, still all real numbers. It doesn't give you any kind of boundaries, so it's going to be all real numbers here. Horizontal asymptote, it's y equals 0. Your range, you carry down the y, you carry down the 0. The graph is above the horizontal asymptote, so you put a greater than symbol. It is a growth. And the y-intercept is the only thing that changes here, 0, 1. Oh, the next one, domain. Still all real numbers. Your horizontal asymptote, still y equals 0. The range, carry down the y, carry down the 0. The graph is above the horizontal asymptote, so it's still greater than. It is a decay because the graph is decreasing. And the 1/2 is smaller than 1. And the y-intercept is 0, 1. On the next one, we have f of 1 of x equals 2 to the x plus 2 power. Domain is still all real numbers. Horizontal asymptote, y equals 0. The range, y is going to be greater than 0. The 2 is bigger than 1, so that's a growth. And the y-intercept, 0, 4. And the last graph, domain, all real numbers. Horizontal asymptote, y equals 0. It's where it looks most horizontal. The range, you carry down the y and the 0. The graph is above the dashed line, so you put a greater than symbol. It's decreasing, so that's a decay. And the y-intercept is 0, 4. (9e) Exponential regressions. On number 1, we're going to look at this. Is it linear or exponential? Well, let's figure if it has a constant change or a constant factor. So from 1 to 2, you add 1. From 2 to 3, you add 1. And 3 to 4, you add 1. Okay, now we're going to look at the y's. So from -2 to 0, you add 2. 0 to 2, you add 2. And 2 to 4, you also add 2. So this is going to be a constant change. It's a common difference. So that means that it's linear. The y-intercept is when x equals 0. So if we went backwards 1, took away 1, we get 0. We take away 2, we get -4. So our y-intercept would be 0, -4. Since this is linear, we're going to find a slope. So we can cross out the base. Our slope would be rise over run, the change in y over the change in x. So it's positive 2 over positive 1. So that's just a 2. So our equation would be y equals mx plus b. Y equals our slope m, which is 2, x plus -4. So just put -4. If you were not sure about this, you could go to the graph. The TI Inspire, you go to this right here, Vernier Data Quest, click on the table, and type in the numbers. Once you're done typing in the numbers, you can click on this graph icon, and then go to Menu, 4, 6, and then Linear. Also, always check to make sure that all of your data points are input correctly. Okay, in this case, R is 1. That's as accurate as it can get. M is 2, B is -4. Now let's just see what we would get if we did exponential instead. Notice this one says argument error. In this case, that would mean it automatically wouldn't work because we have the a times b to the x power, and we have a negative, a 0, and a positive. That wouldn't work for exponential, so you can automatically cross that out. Let's look at number 2, linear exponential. Let's find the change in x and the change in y first. So we're going to add 1, and add 1. For y, that's adding 6, that's adding 12. Oh, they're not constant, so that must mean that's a constant factor. So instead of adding 6, 6 times 2 equals 12. 12 times 2 also equals 24, and 24 times 2 is 48. So you would circle exponential, constant factor. The y-intercept, you would go back 1 space, so subtract 1 to get 0, and divide 2 to get 3. So your y-intercept would be 0, 3. You wouldn't have a slope because this is exponential. Your base is multiplied by 2's. So your equation would be y equals your initial value, which is 3, times your base 2 to the x power. And if you want to put this one in the calculator, you could do that. So we'll go to menu, 4 analyze, 6 curve fit, and then exponential. Notice our R is 1, with A being 3 and B being 2. And that fits the equation we got. Now let's just say we wanted to try to get linear instead. So menu, analyze, curve fit, linear. For this one, R is not 1, it's only 0.959 something. That means that is not as good of a fit. Now let's look at the next one. Okay, so we add 1, add 1, add 1. So that's constant there. Now with 8 to 4, we're going to subtract 4, subtract 2. Oh, look, they're not a constant difference, so that means it must be divided and multiplied. To get 8 to turn into 4, we have to divide by 2. Divide by 2. Divide by 2. That's the same thing as multiply by 1/2. So we have exponential, it's a constant factor. The y-intercept was already given to you on this one, 0, 8. So there's no slope, and the base is 1/2 because we're divided by 2 each time. So our equation is going to be y equals our initial value 8 times 1/2 to the x power. And again, you can always check that with the TI Inspire. Let's do the last one. +1, So all these are plus 1. 2 to 4, you add 2. 4 to 6, add 2. That still works. And add 2. So this is a constant difference, so that's going to be linear with a constant change. Our y-intercept is 0, 2. We don't have a base. Our slope is rise over run, 2 over 1. That's just 2. Our equation, y equals mx plus b. So y equals 2x plus 2. Let's look at the next part, 11a, simplify radicals. So, we are simplifying radicals. You will look for these specific square roots first. The square root of 4, the square root of 9, the square root of 25, and the square root of 49. So 147. Well, it's not an even number, so we can't do 4. 9. 7 plus 4 plus 1 is not divisible by 9, so that would 25 wouldn't work. Let's try 49. 147 divided by 49, that equals 3, so yes, that will work. So divide by the square root of 49. The square root of 3, there's no other perfect squares you could take out of that, so that's left over. So your simplified radical would be 7 square root of 3. To simplify the square root of 96, let's first see if 96 is divisible by 4. So 96 divided by 4. That equals 24, so yes, it goes into it. Now let's see if 4 could go into 24. If you divide that, you'll get 6. And there's no 4s, 9s, 25s, and so on that could go into 6, so that's your leftover. So we have 2 times 2, that's 4, and we have square root 6. So your simplified form is 4 square root of 6. And now we have the square root of 8. Well, we know that we could take out 4. 8 divided by 4 is 2. There's nothing you could take out of 2, so that's left over. So we have 2 times the square root of 2, and that's our simplified form. You can also write out the factors of each of these, the prime factorization. That's another way you could do these. Okay, 11b, we have law of exponents. So let's refer to your properties of exponents, product of powers. That's adding exponents. And then we have quotient of powers. Subtracting exponents. Power of power. Your multiply exponents. And then rational exponent, your dividing exponents. And then for negative exponents, you flip the fraction. And you also change the exponent sign from negative to positive. Okay, so let's look at x to the third power times y to the fourth power times x to the fifth power. Well, we have two bases that are the same, and we're going to use the product of power, so we're going to add those exponents together. So we have x to 3 plus 5 times y to the fourth. So our simplified form would be x to the eighth power times y to the fourth power. Okay, let's look at the next one. We have x times x. Well, when you just have an x with no exponent shown, we actually have an exponent of 1. So we have x to 1 plus 1 power, that's x squared, x to the second power. Anything to the 0th power is 1, as long as it's a determinate form. We have x to the 5th power times y to the 4th power times z all over y squared. So we have a fraction here. We use quotient of powers, that's subtracting the exponents. So we have the 4 minus the 2. So we have x to the 5th power times y to the 4 minus 2 power times z. Now 4 minus 2 is 2, so your simplified form is x to the 5th times y to the second times z to the first. And that's your simplified form. Now the next one, d to the 4th times o to the first times g to the third, all to the 7th power. We have parentheses with exponents on both sides. So we do power of power, multiply exponents. So you multiply that 7 into each of the 3 bases exponents. So we have d to the 4 times 7 times o to the 1 times 7, and then times g to 3 times 7. So your simplified form would be d to the 28th power times o to the 7th power times g to the 21st power. We have 2/3 to the negative first power. We have a negative exponent, so we're going to flip the fraction and change that exponent to a positive. So we have 3 to the first power and 2 to the first power. That's just 3 halves. Okay, we have another one where we have parentheses. So we're going to do power of a power, multiply exponents, distribute that 1/2 into each of those. So we have t to the 12 divided by 2 and x to the 18 divided by 2. So our simplified form is t to the 6th power times x to the 9th power. Okay, the next one we have w to the 0 times o to the first times o to the first times f to the 7th all over r to the 0 times u to the 0 times f to the 5th power times f to the 1st power. Well, let's get all these zeros out of the way. Anything to the 0 power is 1. So that's 1, that's 1, that's 1. And 1 times a number is still that number, so we could just not write them. We have 2 like bases, so we have o to the 1 plus 1 times f to the 7th all over f to the 5 plus 1. Since if there's no exponent there, you assume it's a 1. We have o to second, f to the 7th all over f to the 6th. We still have that fraction, so we're going to do quotient of powers, subtracting exponents. So we have O to the second power times F to the 7 minus 6 power. That's going to equal O squared times F. Let's change x to 3/5 to a radical. So looking at our property of exponents, we look at the rational exponent. That's dividing the exponents. So the n is 5. So this could be the 5th root. And then x to the 3rd power. That's changing it to a radical. M to the 1/2. That's 2m to the 1st power, which you could just write the square root of m. Now let's change these two radicals to exponents. We have a square root of n. That's the same thing as n to the 1/2 power. The index is automatically assumed to be a 2, and the exponent is automatically assumed to be a 1 if there's nothing there. So the cube root of y to the 1st power, you write y to the 1/3 power. Review this, look over it, and good luck on the test on Canvas, Test 7.